Hey friends, we are going to be looking at the area of a trapezium in this video. So let's have a quick look at some properties of trapeziums. So you may notice a few things that are similar between these shapes and a few things that are different between them. So take a moment to think about what they are, pause the video and then make some notes. I'm going to tell you a few things that I notice. So first of all, similarities. So they're all four-sided shapes. So all trapeziums have four sides. Now there's a special name that we use for four-sided shapes. Hopefully you know that. I'm going to tell you that in a second. Another thing that you may have noticed, or I hope you did, is there's one pair of parallel sides on each of these shapes, and one pair, so not two pairs, just one. Another thing you notice is this one here is actually symmetrical around the middle. This one here has got right angles on one side. And then you've got the fact that these two slopes are in opposite directions and these two slopes are in similar directions, or they're both sloping to the left or right depending on which side you're looking at it. So all of these are kind of interesting properties of trapeziums, and we're just going to come up with a nicer definition of a trapezium. Now you'll notice here that we've got the parallel sides labelled A and B. You always label the parallel sides A and B. It doesn't matter which one is A and which one is B. So I could have done, for example, B and A. That would have been fine. And then very importantly, the H here has to be the perpendicular height. So that means it has to be the distance between the parallel sides. Now, when you talk about perpendicular height, it can you can rotate the trapezium, in which case the height would be going sideways. I'm going to show you that in a second. But for the definition of a trapezium, it's a four-sided shape, which is a quadrilateral with one pair of parallel sides. So that's the definition. And here's what I mean by the fact that the distance between the parallel sides does not have to be vertical. It can be horizontal. We can call it the perpendicular height or just the distance between the parallel sides. Either way, perpendicular is very important. Notice that if I look at this distance here, or this distance here, or this distance here, that's not the distance between the parallel sides. It's just random length. So let's look at some properties of trapeziums. Pause the video and decide whether the following are always, sometimes, or never true. And then I'm going to go through it with you. Okay, so first of all, a trapezium is a quadrilateral. This always has to be true. A and B are parallel. This is always true. You do not label the other sides. A is always the top and B is always the bottom. Now, I mentioned to you that it doesn't matter which side is A and B. So this is sometimes it's true that A is the top and B is the bottom, but not always. A and B are horizontal. This is, remember, you can have trapeziums that are at an angle like this, with the two parallel sides being vertical. So this is a case of sometimes they are horizontal, sometimes they're vertical. H must be perpendicular to A and B. This is definitely always true. A is shorter than B. Now this doesn't necessarily have to be true because, for example, if A was the top, might be the shorter side. If A was, A could also just be the longer side. So you can rotate these. Now this is sometimes true, and then you can always use the slant height to find the area. In this case, we're going to say never true, although when you go to get to Pythagoras, you may find that slant height might be useful for you to work out more information. But for now, we're going to say never. Okay, so how do we find the area of a trapezium? There's lots of ways that we can do this. I am going to show you a few ways, but I'm going to stick to one kind of main method. So here's just a standard trapezium. You've got one pair of parallel sides, which are these two sides here. Now, if you draw a line from one vertex to the next, to another vertex going across the shape, so I'll do this in, let's do it in red. You were to cut a trapezium in that way, and remember it can be any trapezium. So the trapezium might, for example, look like this. It's just a rough sketch here. both of these cases, and you can come up with lots more cases. If you were to cut it along and then move that triangle to the side, what you find is you end up with two triangles. Now we know what the area of a triangle is. So the area of a triangle is half times base length times height. Now in this case the triangle is kind of upside down if you want to look at it that way. A is your base length here, so half times, now I'm going to use A, and B stands for the base length, but in this case we're looking at A, times the height. This is the perpendicular height, and sometimes we put a small p there, so times h, p, perpendicular height of the triangle. We're also going to add up this area. So we worked out area of 1, and we're going to add that to the area of 2. We're going to combine this together. So in the second shape, we can see that the area of this triangle is half times base length, in this case it happens to be called b, times the perpendicular height. Now we need to add these together. So half AH plus half BH. So if we write this in a slightly nicer way, half AH plus half BH, we can actually factorize half and h out. So if you think about bus stop division, we can actually do that here, and we can take half h out, and we're left with a plus b. Now I'm not going to go into too much detail if you didn't follow that, but this is basically the formula: half h times a plus b. And the way that we normally write it is we normally put the h at the end, so half a plus b times h. And then a small p down here which refers to the perpendicular height. So a and b are the lengths of the parallel sides. So I just showed you where the formula came from. There are other ways to do this, but we're going to just look at this particular method here. And this is what you need to copy down if you don't already have it. So the area of a trapezium is half a plus b times height, where a and b are the parallel lines and h is the perpendicular height. So pause the video and copy that down. Now I'm going to show you some animations here. So you don't need to know how to prove these, but these are just visual ways of looking at area of a trapezium. So for example, here is just a standard trapezium which I can actually manipulate. I can change these various things, but I know that the base and the top are parallel. Now if you were to slice this through the middle, or actually if you were to rotate it around the midpoint, you end up with a parallelogram. So the area of a parallelogram is base times perpendicular height. Now if you work out base times perpendicular height here, you've actually worked out the area of two parallelograms. So if you were to half that, half base times perpendicular height, and in this case the base is actually a plus b because it's the bottom length and the top length. I haven't gone into too much detail here, but hopefully that you'll see some ideas here. Here's another interesting way of looking at it. If you were to cut the shapes straight down from the middle and then flip it up, you end up with a rectangle. Another way to look at this is cutting through the midpoint to another vertex. And then the other way is using a slice through the center across, and then there's another final method here, is kind of similar to the one that I showed you earlier in the video. So in the next video I'm going to show you how you can use this formula and how we can apply it in various questions.